In order to figure out the 6 trig ratios for theta on this question, we are going to use a strategy that we are going to use a lot in this unit and the next unit. That strategy, since we're doing trigonometry, I call this strategy draw a triangle. Huh? Seems to make sense for trigonometry to draw a triangle. Now, we have the point -1, -4. If we draw our 4 quadrants and we label where -1, -4 would be, it would be there in quadrant 3. Now that we have that point, if that is on the terminal point of an angle in standard position would start here, and if it's a terminal point, that means that angle ends there, going through that point, we can draw a triangle. Now when we draw our triangle, we always draw our triangle back to the nearest x-axis, because what's this angle called right there? What's the angle back to the nearest x-axis called? That is our reference angle. So tell me, what do you know about this triangle? Do you know anything, any of the measurements on this triangle? The length of this side will be 1. The length of this side will be 4. And the length of the hypotenuse will be? Square root of 17. Excellent. One thing you're going to get really, really good at in this unit is doing a squared plus b squared equals c squared in your head. So 1 squared plus 4 squared, 1 plus 16 is 17, so a hypotenuse will be the square root of 17. Now the reason that this triangle is important is once we've drawn this triangle, we can figure out what sine of theta is. Because sine of theta is just the opposite over the hypotenuse. And since the opposite is 4 and the hypotenuse is square root of 17, we're going to get 4 over the square root of 17. In addition to that, we also have to think about where is this one ending up? This is ending up in quadrant 3. What do we know about quadrant 3 and sine, cos, and tan? According to the CAS rule, there's a t in quadrant 3. What does that t mean? Terrific? Tan? So what does it mean about tan? Tangent is the only positive one. So if sine is in quadrant 3, it's going to have to be negative. Now in grade 11, whenever you had a square root on the bottom, what do you have to do? Rationalize the denominator. In grade 12, they assume you learned that in grade 11, and they assume you can do that 100 times out of 100. So they'll let you leave it like this because they know you can change it. So you don't have to rationalize the denominator in grade 12. You could leave your answer as -4 over the square root of 17. However, if it was a multiple choice question and that wasn't one of the answers, but -4 square root of 17 over 17 was the answer, they're assuming you'd be able to change it to make it look like that so that you would get the multiple choice right. So that's kind of nice. You don't have to rationalize. Yes? Not always. So sometimes they might be, but sometimes they're not. Yes? Because it's in quadrant 3 and sine is negative in quadrant 3, the whole fraction's negative. You could put the negative in front of the fraction or a negative with the 4, it wouldn't matter. Can you see that cos of theta? Cos is the adjacent over the hypotenuse. And because it's in quadrant 3, will it be positive or negative? Negative. And tan of theta, opposite over adjacent. Will it be positive or negative? Positive. So those are our 3 trigonometry ratios. Those are the primary ones. Now we can do the reciprocal ones. So the reciprocal of sine is cosecant. The reciprocal of the reciprocal of cos is secant, and the reciprocal of tan is cotangent. And since they're reciprocal functions, this means that I'm going to have 1 over sine, but what that does is whatever answer sine is equal to, since cosecant is the reciprocal of it, it's going to equal, oops, I should go green. See what happened? And when you flip a fraction, if it was negative before, can you see that it would stay negative? So secant's going to equal, and you can write over 1 or you wouldn't have to. And cotangent is equal to 1 over 4. So if we draw a triangle, we can get all of our primary ones directly from the triangle. We use our cast rule to determine whether or not they're going to be positive or negative, and then we can easily find the reciprocal functions as well. So this idea of drawing a triangle is very powerful. When you look at your example in your textbook, I think they do it in a more complicated way, in my opinion. So I think drawing the triangle will be the easiest way to solve for this. Question number 8 is one you can do for this.